Some thunderstorms do not just grow tall and rain themselves out. They organize, rotate, and keep feeding on warm, moist air for long enough to become one of Australia's most dangerous storm types. These are supercell thunderstorms, and the key feature is a rotating updraft called a mesocyclone. That rotation helps the storm keep its structure together, so the updraft can keep rising while the heaviest rain and hail fall away from the inflow. In a normal storm, rain and hail can drag cool air down through the same area where warm air is trying to rise, and the storm often collapses. In a supercell, wind shear tilts and organizes the storm, separating the rising air from the falling rain and hail. That is why a supercell can last for hours and produce more than one severe hazard. The ingredients matter. Forecasters look for strong, deep-layer vertical wind shear, which means winds change speed or direction with height through a deep slice of the atmosphere. That change can create a rolling tube of air, and a strong updraft can tilt that spin upright. They also look for CAPE, or convective available potential energy. In simple terms, CAPE is the fuel that tells us how strongly air may rise if a storm gets going. CAPE helps the storm punch upward. Wind shear helps it stay organized. Australia can get this set up when warm, moist air near the ground meets stronger winds higher up, with a trigger to lift the air into the storm layer. This is common enough in the eastern states during severe thunderstorm season, especially when inland heat, coastal moisture, and upper-level winds line up. But supercells can happen in other regions too when the atmosphere has the right mix. On radar, the Bureau of Meteorology watches for signs that a storm is rotating and becoming organized. A hook echo can appear when rain and hail wrap around the mesocyclone. An inflow notch may show where warm air is feeding into the storm. Doppler radar can also show a velocity couplet, where air on one side moves towards the radar and air on the other side moves away. That pattern can point to rotation inside the storm. A hook echo or velocity couplet does not automatically mean a tornado is on the ground. Supercells are famous for giant hail because very strong updrafts can hold hailstones aloft, letting them grow before they finally fall. They can also produce damaging winds when downdrafts surge out from the storm, heavy rain that causes flash flooding, and in some cases tornadoes. Not every mesocyclone makes a tornado, but any rotating severe storm deserves respect. If a severe thunderstorm warning is issued for your area, do not wait for the sky to look dramatic. Move indoors, stay away from windows, secure loose outdoor items if there is time, and never drive through floodwater. Keep checking Bureau updates because supercells can strengthen, turn, or change hazards quickly. The safest response is early action, not last-minute reaction.